you all have actually taken up this initiative in a real sense, and I this is the second symposium. You might have heard done a lot more, but two of them which I had requested, so you have fulfilled my request as far as these are concerned. The earlier one, which was on open access, and it was actually taken very positively by all the participants. I had got a lot of feedback regarding its positive inputs which have been given in that, and a larger lot has been basically uh, could get the knowledge base which was required for open access. And in that series itself, again, this webinar also will be very, very important, because as Piyush, you have rightly pointed out that Indian Railways is planning to upgrade its speed potential to 160 kmph, and in that context, initially, I am very sure most of our friends will be knowing, but then at the cost of repetition, that Indian Railways, for Indian Railways, for 160 kmph upgrading the speed, estimates have been sanctioned for Delhi, Mumbai, and Delhi, Howrah routes, and in which the upgradation of traction installations also to fit to be fit for 160 kmph have also been sanctioned. So in that itself, this upgradation of the traction installations to 225 kV systems would have to be undertaken. And in that direction itself, a decision has also been taken that whenever new upgrades are to be done, they would be done on 225 kV systems. Like in next in line in that is the rest of the other four DDGQ routes, which would be taken up, and in that also a decision has been taken that 225 kV systems would be put. And the point is that to start a greenfield project with a 225 kV system is a different ball game. But with the existing system in our conventional 125 kV, and then going in for 225 80 system is something which would need much more perspective of the things to understand the basics, that how it is different from a 2 into 20 1 into 25 kV conventional system, and then how to basically convert and understand the whole philosophy behind this, so that overall it is beneficial to the railways. And there was a lot of study undertaken, and we have been doing this thing for last so many years, but now a time has come that we will be upgrading our systems to 2025 kV system 80 systems. And as means it also basically is a beneficial system. Otherwise, if we had to go in for normal conventional systems, many more TSSs would have had to come, which I am means when Piyush takes, he will deal it in detail and tell what are those advantages that we have in 25 kV systems. And in this direction, I must appreciate the efforts which have been put by the railways in getting these estimates sanctioned. They are all means we feel very, very proud to be that we had reduced our costs also to a very large extent, and got the estimate sanctioned. And now it is time that those further tenders will have to be done, and the works will have to be executed. In that direction, again, the railways have taken a lot of initiative, and in both Delhi, Mumbai, as well as in Delhi, Howrah sections, as of now, the OHE modification works, which would require major blocks, have already been initiated, and approximately 300 TKM in each route has been converted to those upgraded systems, so that whenever we are ready for the 225 kV systems, those means the OHE will be fit for that. So I must compliment all the railways who have taken up this initiative and are going ahead with that. A lot of innovative approaches have also been adopted by the railways, in for which would also, I think, tomorrow that would be discussed. and means the participants can benefit from it. So with these words, I would like to I would not come in the way for Piyush to take the things forward and have a very informative and benefited session for everybody. Thank you. Piyush, by the way, how many participants today? Unmute karo.
Thank you, sir. Thank you for sharing your words of wisdom and informing about latest happenings of railways as well, vision of Indian Railways as well. Sir, total 630 have joined, and out of 630 officials, approx 200 are from IRIN itself. They are undergoing various trainings. And
Okay, wonderful.
yes, sir. And officers are still joining, and perhaps our capacity is 750 or 1,000. So still lot of scope is there, and people can join right now.
Thank you so much.
And thank you, sir. Thank you for board to have shown faith on IRIN. And today's lecture basically will be on fundamentals of upgrading speed potential to 160. That is OHE and PSI 2 into 25 kV. So I'll share my screen so that I may be better able to explain the things I want to convey. Sir, whether my screen is visible now? Is this visible, sir? Yeah. Participant list I need. So I am making an arrangement like this. Thank you. So basically today's lecture is fundamentals of upgrading speed potential of Indian Railway to 160 kmph. And as such, 2 into 25 kV system is not new in world. And if you see the list, I'll choose one pen also so that in the list of having this technology, name of Indian Railway and DFCCIL is also available. In advanced countries, from conceptualization to implementation, normally they take not more than 4 years. And keeping 2 into 25 kV as in a mission mode, Eastern Railway on 9 September 2020, they have already started the conversion of their overhead equipment. PCE Eastern Railway, Sri C.S. Jingar Saab, accompanied by CED Eastern Railway and staff of OHE, the inauguration have already been done. On the slide, you will be able to see some modification work on OHE is going on. So we need to understand overhead equipment, OHE and PSI, basically what we are going to do. So instead of 667, now it is having 800 kg of weight, 20 into 40. Some changes are there in ATD as well. One by one, we'll understand the need and the basic concepts. So I'll begin with a very basic of overhead equipment, OHE, and actually this online platform has got many features. It has got chat box. It is having various polls wherein I can interact with all the participants to give a feeling that we all are sitting in a big hall and learning a new subject. So this is a very uh, basic circuit. One battery is available, resistance is available, and it so happened that it is now connected to a short circuit. So I am now generating a pole, and the question is, what shall be the short circuit current? So on your screen, there will be a question, and I request participant to please answer, because time limit is only 1 minute. So what answer I am getting is now 100 ampere, very high towards infinity, very low, and zero as well. Right now, very high towards infinity is winning, and it is approximately 60 now. There is a time limitation. Please submit within 10 seconds. So poll is closed now. Now still 20 seconds remaining, and responses are coming very fast. So now poll is now closed, and I'll try to show you the result. So you might be able to see the result. Many have answered that there will be high current towards infinity, and as we know that if we give 4 answers, people are likely to answer from all the objectives, all the given options. But now let us understand this basic concept, then we'll go ahead. This is the concept which says why system earthing is needed, basically. So it so happened that positive terminal of the battery has been connected to a earth terminal, and since to flow current, the electric current need path, and there is no return path, and therefore zero current will flow. सरल शब्दों में मैं कहूं तो एक बैटरी के पॉजिटिव टर्मिनल को आपने अर्थ में जोड़ दिया है, नेगेटिव को तो आपने कुछ किया ही नहीं है, तो करंट कैसे फ्लो हो सकती है? Until unless negative is also connected to earth, current cannot flow. So this basic principle we have utilized in our TSS, and what we did is that let me open chat box also, so that in case my voice not coming or any other queries are there, I'll be able to have a look on them. Okay. So whenever voice is not there, please write on the chat box. Because of the online constraint, I have kept everyone mute. Okay. So what we do, we take a transformer, and one of the secondary of the transformer, we make it solid ground, and another wire goes to 25 kV, and then through pantograph it receives energy, goes to transformer, then of course motor, then mechanical energy, and the return current through wheels, it goes back to rail. And we all know that our system is 50 hertz, and rail, if any current flows on rail, it will having some flux and therefore inductance, and because of that most of the current flows through earth, and some say 10-15% of the current returns through rail as well. So rail is earth, transformer secondary is earth, and the current closed circuit takes place. So what is the need? Why do we do that? It is so because for any design of a system, we think of safety first. Why safety first? Because humans are involved for its maintenance as well. So rail potential has to be kept on low potential, and for that earthing bonding also we provide. But again, why such kind of system we have adopted? Actually, for the safety, we want that in case if our overhead equipment OHE falls on say ground, so we need high current to flow so that our relay act. And all our structures like poles, etc., masts, etc., everything, even foot over bridge, we make it earth, so that in case life touches to earth, because life touches to mast, because of the bonding available, the return current flows and our relays act and they will disconnect it. What happens if current doesn't flow? Like there is a mast, but we have not connected the bond, and live OHE, 25 kV OHE is touching to mast. What will happen? It will get high resistance, high impedance, and because of the high impedance, the current will be very low, and there is likely that our relays don't operate. So what we have done, we have provided a delta current, delta I relay, which takes care of such situations. Even though I have muted all the participants, but there is a flaw in this WebEx. If any system which doesn't system is not compatible with the WebEx, participant can unmute. So I request participant to keep muted. I'll again mute all and keep their video off, because some 675 people have already joined. So keeping video off will basically reduce the requirement of bandwidth. So let us just in brief have a look what I was telling now. So this is the point where I was saying that the system earth is there, and then of course current flows to the OHE. We all know that. Sorry. And one more thing is there, the current which flows to the ground, it goes down up to 450 meters. And because of the large volume of the earth, it is very difficult to analyze which way current is going. And this earth current, they are causing corrosion to various equipment buried inside the earth. If you see this diagram closely, there are two tappings. In this diagram, red and blue phase, RYB 3 phase होते हैं, और इसमें से 2 phases we are taking. But from the fundamentals we know that we need a balanced system. अनबैलेंस होता है तो उसको फोटोस्क्यू थ्योरम से हम एनालाइज करते हैं, उसमें पॉजिटिव सीक्वेंस, नेगेटिव सीक्वेंस एंड जीरो सीक्वेंस करंट आ जाती है, एंड लॉट ऑफ इल इफेक्ट्स आर देयर. सो दिस सिंगल फेज, this 1 into 25 kV, the conventional overhead equipment system is technically having some limitations. We are taking 2 phase, although we are rotating it, and we are presuming that equal trains are available on various sections, but practically it's not true. So there is a need to devise something else which takes care of problems associated with 1 into 25 kV system, and one of the problem is EMI interference. That all we will see one by one. So in 2 into 25 kV, what happens? Instead of 2 phases, we are taking 3 phases. All 3 phases will come to our traction substation. And this is a TSS, and then power comes to OHE. And if you have a close look to the pictures being shown on your computer or laptop or your device, there is one is catenary, the bottom one is contact wire, and one more wire, I have rounded it, known as feeder wire, is also running. So from here itself, you can understand that while implementing, we need to bring another third phase to our traction substation. And third phase means, again, we have to see fundamentally whether their structures are capable to take care of another load, and capacity, our state electricity board, they are having the capacity to give us. So all these implementing issues we will see tomorrow. So it's a close-up now, close-up of that feeder. So this is the feeder wire, the OHE we know, and this is basically a photograph of DFCCIL. And one more conductor we are able to see. This is earth wire. So one earth wire also moves on the pole. And any technology, you all will agree with my viewpoint that it should be learned from the first principle. First principle means, let us take an example of chef. Just a moment, please. Chef and a cook, both are preparing food, but if you take example of tea and ginger is not available, cook will simply raise hands कि यार भाई मैं नहीं करता, कुछ नहीं कर सकता, because मुझे नहीं पता, मुझे तो बताया गया इस तरीके से बनाना है. But what chef will say, अरे भाई कोई बात नहीं, salt है उसको डाल दो, काम चल जाएगा, because he knows the first principle of things. So here also we need to understand the first principle of our technology. So if our first principle is known, then we can easily answer all the questions like whether feeder is to be erected OHE side or opposite to OHE. Can we erect feeder this side? Or say in 2x25 kV there is a auto transformer also. So what if auto transformer fails? What if last auto transformer fails? So if you know the technology while implementing, we can trade off the situation. So in brief, I would like that these 4 points to be read out. What we are going to do with overhead equipment. So we are running a feeder wire, we are running a earth wire. Are you able to see my presentation? Because I have opened on mobile also, but in mobile I am not able to see. Can you please write on the chat box? Just 1 or 2, if someone answers, then need not to answer again. So in my mobile, PPT is not coming anyway. Answers are yes. Please stop writing because otherwise it will be clutter. So it's there. It means everything is fine. Okay. Rather I'll switch off my mobile because sometimes it so happen that वो loop में चला जाता है तो फिर only option is that you have to log out and then log in again. So feeder we are providing, earth wire we are providing, and tension we are going to for 1200 kg. Why? Everything we'll see later on. One again thing. Can we achieve 160 kmph with 1 into 25 kV also? Yes, of course, yes. But there are some limitations we'll see in further slides. So if we need modification, so we need to do modification on 1 into 25 kV as well and 2 into 25 kV as well. Now we are building up key why we are going for 2 into 25 kV. And PSI work means capacity augmentation we have to do. And right now there is a capacity means our OH is not able to take the current we desire. So this we are going to see. And if we see 2 into 25 kV, So capacity augmentation means Scott or V connected transformer and one more auto transformer. Switching stations, yes, there are switching stations SP, SSP, and we need single pole breaker. And here 2 into 25, 2 itself says ki everything is double. So basically OHE will be having 2 babies and we have to take care of both the babies. So what are those 2 babies? Basically is conductor OHE means catenary contact तो रहेगा ही, साथ में फीडर वायर और आ गया है और फीडर वायर आ गया उसमें भी करंट फ्लो हो रही है, तो वी नीड डबल पोल ब्रेकर्स देन. So these are just a bird eye view what we are going to do. So I have arranged my presentation in 2 forms, OHE and PSI separately. So OHE being simple, let us understand what we are going to do on our overhead equipment. And I believe participants have already registered on the link we have shared. And after registration, you will be getting one link to download all the PPTs. So technology, PPTs, everything we have already shared. Just I'll have a look on chat box if anything is written. Questions are there, but please wait and everything will be answered in my presentation. So now have a look how is our OHE and what we need to do. So it so happens that when a locomotive runs, it has got a pantograph, and pantograph is pushing our OHE with a pressure of 7 kg. So if you take a snapshot, the OHE is not going to be on its position, it's going to be lifted because of the pantograph, and train is moving, so it will leave its position. So what happens afterward? Afterward, this OHE is going to come down. And will it come on the same place? No. From the first principle, we know that because of the inertia, it will go down. So this is the snapshot of one position, and since the train is moving at a speed, this is now going to create one traveling wave on our OHE also. And it so happens, and we know that our pantograph will also bounce. Pantograph का जो design उस पे हम लोग नहीं जा रहे हैं, but we know plunger boxes are there, springs are there, and it's designed to take care of the track and so many things. So pantograph also bounces. So there can be a position where pantograph goes down, and because of this traveling wave, whatever we have read in the second year of engineering, electromagnetic wave. So similarly in our mechanical system, such wave are getting, and this wave is going to cantilever, and from there it is going back, means reflection. So getting complicated, and the moment where pantograph goes down and OHE goes up, there is a problem. What problem? Problem of loss of connection. It will create now spark. So our OHE is basically fit for 160 kmph, and I'm just logging out from my mobile because it's not serving any purpose now. Just a moment. Yeah, it's now hang and not responding as well. Anyway, just a moment. So our OHE is designed for 160 kmph and to be operated for 140 kmph. And if we want speed higher than this, then there is a need to modify our OHE. And why to modify this? What all we are going to see. So there are standards 50119 and many which says that if traveling wave velocity is v, then the velocity of vehicle should be 0.7 v. So how to find out the velocity of v, traveling wave? Then only we can decide the velocity of our vehicle. So though the velocity is basically some constant under root of tension upon mass of OHE. So every technical problem has got a technical solution. If we increase tension, then we are going to increase our velocity. So what we have decided, we are going for 1200 kg of tension. What is our tension right now? 1000 kg on contact and catenary. What we are going to take 1200 kg on contact and 1200 kg on catenary system. This OHE then will be fit for say 180 and we are operating at 160, and why not at 200? So again the concept of elasticity comes. Basically when for proper current collection, for what we are doing all this thing, who is our customer? Who is customer of OHE? It is the pantograph. So for proper current collection, the upliftment of OHE, which is called elasticity, or if we go more technically, it is upliftment of OHE per kg push of pantograph. So elasticity of OHE should be equal at support and at midpoint. If it is so, then perfectly no sparking. And to achieve at 200 kmph, we need stitch catenary. The support itself is modified with the formation of V and then with the dropper. So our OHE is not designed like that, and we want that existing OHE should be modified. And for high speed also, there is a definition that if the existing infrastructure is modified to 200 kmph, we will be in the club of high speed trains, or in a green field if it is more than 300 320, it's high speed. So separate high speed project is already going on, and what we have decided is that our speed is going to be 160 kmph. Further, our OHE is designed for push-up of 3 pantograph, means consist single loco, double loco, and consist. Consist means 3 loco we are able to operate. If there is a 4th pantograph or more, we need to think of that current collection is proper.